All right, hi Math 7 students. We are going to start this recording to help you prepare for the test. The test is going to be moved to May the 4th, so a week from this Wednesday. I want to encourage you guys to practice all the questions on this recording. The questions will be really similar to those in the test. Also, when you do the test, remember to show part marks on the test, or rather to show, I should say, full solutions. And if you show full solutions, you'll get part marks on the test, even if you don't have the answer correct. But it will be necessary to show full solutions to get the full marks for the question. So please show full solutions whenever you can. Practice all these questions. If you have any that you're not sure about after doing this recording, please give me a shout. So we'll start it off with a little cartoon here. And so here's the guy at the movie theater. He says she couldn't change a $20 bill. So of course that's part of the reason why we want math skills, so we can do things like changing $20 bills, right? Anyways, I just thought that was a cute little cartoon to start us off with here. So we're just going to review how to solve equations. And we've seen that equations are kind of like a scale. And so the left side of the equation is always equal to the right side of the equation. And you can see here we've got 3 plus 2 equals 5, and on this side we've got 5. So 5 on this side equals 5 on that side. Now whenever we solve an equation, our goal is always to end up with something like x equals 5. In other words, some variable, could be x, y, b, or whatever, equals some number. That's what we want to end up with by the time we're done the equation, solving the equation. So that's what all of the steps are geared towards. So we're going to start by looking at one-step equations, and these are equations that can be solved by just carrying out one step. So some examples of one-step equations are x plus 5 equals 10, 5a equals 10, and a over 5 equals 10. Now, I got something here. It says secrets of mental math. So we're going to use mental math, first of all, just to remind us that with simple equations like one-step equations, we can actually solve them in our head, and we can get the answer that way, but again, it's important to show the steps in solving the equation so you can get full marks. So what this really means, x plus 5 equals 10, is some number, x stands for some number, so some number added to 5 equals 10. What do you think that number is? Well, it would be 5, right? So x would be 5 here. Okay, we'll go on to the next one. 5a equals 10. Now, a stands for some number, so 5a means 5 times a, so 5 times some number equals 10. What do you think that number is? What is a? Well, it would be 2, right? 5 times 2 equals 10. Okay, looking at the next one, a over 5 equals 10. That's like some number divided by 5 equals 10. Well, that number would be 50. 50 over 5 equals 10. Okay, so that's how we would do it if we were just kind of solving it in our mind. That's what we call mental math. But we're going to look at the steps we use when we're using actual math operations. So what we always want to keep in mind is when we're solving a one-step equation, we always want to use the opposite math operation to the one that's shown in the equation. So if in the equation we have something being added, then we do the opposite of plus, which is minus. If we have something divided, the opposite of divided is times, and vice versa. So we always use opposite math operations. All right, so for an example, we solve an equation that involves addition, like this one, by subtracting. So because we have x plus 5, we want to end up with just x on the left side of the equation. So because we have plus 5, we do the opposite of plus 5, which is minus 5. So we do minus 5 on both sides of the equation. You can see that the plus and minus 5 cancel out and give us 0. So we're just left with x on the left, and 10 minus 5 gives us 5 on the right. Okay, so again, we solve an equation with addition by subtracting. This situation here, this equation, we have 5a, which is the same as 5 times a. What's the opposite of times or multiplication? That's going to be division, right? So instead of times 5, we're going to divide by 5. So 5a divided by 5, we have 5 on top, 5 on bottom. That cancels out to just a on the left side. We're also going to have to divide the 10 by 5 because whatever we do to one side of the equation, we have to do to the other side. 10 divided by 5 is 2, so our answer is A equals 2. Okay, so we solve an equation with division. A divided by 5 is division, right? With the opposite of division, which is multiplication. So instead of dividing by 5, we're going to multiply both sides by 5. So the 5 on top, 5 on bottom, cross off, and we end up with A. 5 times 10 is 50. A equals 50. Now again, it's always important to check our answer when we solved an equation by plugging our answer back into the equation and seeing that the left side of the equation equals the right side. So when we plug in x equals 5, we put 5 in where we see x. That's 5 plus 5, which is going to give us 10 on the left side. We've already got 10 on the right. Both sides are equal. We know we did the equation right. Okay, we're going to practice some one-step equations. So if you look at this one here, think about the fact we want to end up with the x on the left side of the equation, some number on the right. So if we want just the x on the left side of the equation, what do you think we need to do to both sides of the equation to get rid of whatever's not with, or rather whatever's with the x? Well, since we have minus 7 with the x, we have to add 7 to both sides. So the numbers cancel out and leave us with the x. We add 7 to the 14 on the right side, gives us 21. Not too bad, right? Okay, another one-step equation. What do you think we need to do to both sides to solve this equation? We have 6 times a. What's the opposite of times 6? Divided by 6, right? We do that and we end up with a on the left. We divide 18 by 6 and we end up with 3 on the right. Okay, how about this one? We're dividing a by 4. The opposite of dividing by 4 is what? What are we going to have to do to both sides of the equation? The opposite of dividing by 4 is times 4. We multiply both sides of the equation by 4. The 4's cancel out, leave us with a. 4 times 16 is 64. All right, so those are all one-step equations. You just have to do one process, which again we said was the opposite math operation to solve the problem. When we look at two-step equations, they're going to require 2 math operations to solve them. So here's an example of a two-step equation. So again, we're going to use 2 opposite math operations to the ones that are found in the equation. So if we're solving this equation, which 2 math operations are found in the equation? Well, we have 3x, which is the same as 3 times x, so we have times, and we also have plus, so we're going to use the opposite of times, which is division, the opposite of plus, which is subtraction. Okay, now the important thing to remember, when we have 3x plus 2, we always want to get rid of that plus 2 first of all. So first of all, remember, we want to get rid of any number that's either added to or subtracted from the variable term. 3x is the variable term. It contains the variable x, and so we want to get rid of the plus 2 because it's being added to the variable term 3x. So what's the opposite of plus 2? That's going to be minus 2. So the first thing we do is subtract 2 from both sides of the equation. 2's cancel out. 2 and minus 2 leaves us with 3x. On the right side, 11 minus 2 leaves us with 9. Now we have 3x equals 9, and that's a one-step equation. We can solve that one. We have 3 times x. What's the opposite of 3 times? Well, the opposite of 3 times is divided by 3. That leaves us with just x. 9 divided by 3 leaves us with 3 on the right. So that's what we do for a two-step equation. We do the opposite of the 2 math operations that we see, and the first thing we always want to do is get rid of the number that's either added to or subtracted from the variable equation. All right, so let's try our hand at this two-step equation here. So look at it here, and what do you think we need to get rid of first? And what step do we use to get rid of that? Well, we need to get rid of any number added or subtracted from the variable term, which is 4b, so we get rid of the minus 3. The opposite of minus 3 is plus 3. So we have to add 3 to both sides of the equation. So you can see here we have minus 3 plus 3. We're going to add 3 to the other side as well. We're going to end up with 4b on the left. On the right, 13 and 3 gives us 16. Now we have 4b equals 16. What do we need to get rid of now? 4 times b. What's the opposite of 4 times? What step are we going to use? The opposite of 4 times is divided. We're going to divide both sides by 4. That gives us b on the left. 16 divided by 4 is 4 on the right. Not too bad, eh? Okay, so we've looked at how to solve one-step equations and an example of a two-step equation. Now let's look at how to create an equation using a pattern, so using a diagram. So this question says, come up with an equation to find the figure number that will have 43 squares in it. So in other words, somewhere down the line we're going to have some figure that's going to have 43. Okay, so we can see here that we have both green squares and orange squares. We're going to have to come up with an equation that helps us figure out both. So the green squares we can see are the same amount for each figure. They're always 3. But how much are the orange squares going up by each time? Well, if we count them, we can see there's 1, 2, 3, 4, figure 1, 8, figure 2, and 12, figure 3. So 4, 8, and 12. So when we're coming up with an equation to find the total number of green squares and orange squares, somehow we're going to have to relate 4, 8, and 12 to the figure number. We're going to have to take the figure number, such as figure number 1. What do we do to that to get the number 4? What do we do to figure number 2 to get 8? Okay, so how can we use the figure number to help us find the number of orange squares each time? That's something we have to think about. Okay, so what we can do is we take the figure number, such as figure 1. Figure 1 has 4 orange squares. So we multiply 4 times 1 for the figure number. That's going to give us 4. That gives us the number of orange squares. For figure 2, we saw 8. So we multiply 4 times the figure number again, which is 2. And that will give us 8 squares. 4 times 3 gives us 12 for the third figure. Okay, so 4 times the figure number equals the number of orange squares. In other words, 4f stands for the number of orange squares. So that's what we're going to use in our equation. We use 4f. So now what we need to do is come up with an equation to find the total number of squares for each figure, the green squares and the orange squares. Well, we said that 4f stands for the number of orange squares, and 3 is always going to be the number of green squares, right? No matter which figure number we're talking about, we always have 3. So we're going to add 4f plus 3, and that's going to give us the total number of squares each time. Okay, so if we look at that for the first one, we can see figure number is 1, so 4 times 1 is 4, plus 3 green. 4 plus 3 is 7. That's the total number of squares. When we count them, we get 3 green, 4 orange. That equals 7. So this equation works for the number of total squares. Okay, so now what the question says, the question told us we need to find an equation to find the figure number that will have 43 squares in all. So when we have 4 times f plus 3 equals the total number of squares, the question tells us that the total number of squares is going to be 43. So instead of saying 4f plus 3 equals t, since t is 43, we're going to have 4f plus 3 equals 43. Now we can solve this equation, and we have to find f. That's the figure number. We're trying to find which figure number will give us 43 squares in all. So we're going to solve this equation to find f. Okay, so to do that, 4f plus 3 equals 43. We solve this like we did before. We have 3 added to the variable term. We're going to have to subtract 3 from both sides. When we do that, we end up with 4f equals 40. And then remember, since we have 4 times f, we do the opposite of 4 times. We divide both sides by 4. We end up with f on the left. 40 divided by 4 is 10 on the right. So the figure number that's going to have 43 squares in it is going to be figure number 10. All right, so we looked in some of the lessons at how we can use models like this, pictures, to stand for equations. Now in this picture, the square stands for the variable like x, and each one of these little circles stands for numbers. So we want to look at this picture and be able to figure out what equation does this stand for. Well, this is the left side of the equation, and this is x plus 1, 2, 3. So that's x plus 3, and we write that down, x plus 3. The right side of the equation, we have just the number 5, circles and all, so that stands for 5. So x plus 3 equals 5 is what is the equation that this diagram stands for. So, using that idea, looking at this diagram, what equation do you think this would be? Okay, well, it's going to be x plus 2 equals 6, right? Good stuff. All right, so now we're going to practice at this point being kind of a language translator, right? I don't know if you guys have been to other countries. I don't know if you speak another language. Parlez-vous le français aujourd'hui? Oui, oui. Anyways, that's my French, not too good, as you can see. I did actually live in Quebec when I grew up, but it's a little rusty at this point because I moved when I was 10. I really enjoy speaking languages, though. I can count to 10 in Japanese, too, but anyways, just for a little halftime entertainment there. So anyways, so what we're doing at this point is going from English statements, so in other words, math in words, into math in symbols. So for instance, if you had this English statement, k is equal to half of n added to 4 times n, all we do is we take, you can see that I've kind of matched up the words, or rather letters I should say, using certain colors. So I just put k is equal to, I put the equal symbol, half of n, I write 1/2 n, added to, I write plus, 4 times n, I write 4n. So this here is the math symbols that stand for these math words. Okay, so that's what we're doing at this point, changing math words into math symbols. All right, so let's give it a shot. The sum of a number and 19 is 35. So what do you think you would write down as the equation for this here? Just give you a few seconds to think about it. Okay, so the sum of a number and 19 is 35. N plus 19, so a number and 19 is like the sum of a number and 19 is 35 is like equals 35. So n plus 19 equals 35. All right, so for the next one, B, it says when you multiply a number by 9 and subtract 16, the result is 47. Okay, so when you multiply a number by 9, the number is n, so it's 9n. And then subtract 16, we just write minus 16. It says the result is 47, so we write equals 47. So this here is our equation. All right, so let's look at how to apply that into a math problem. So Andrea has $73 in her bank account. She takes out $5 every week. A says, write an equation to show the amount of money in Andrea's account after W weeks. So W stands for weeks. All right, so she starts off with 73, so we write down 73 in the beginning. She takes out $5 every week. So it's minus 5 times the number of weeks. W stands for the number of weeks. So we say minus 5 times W. and we write equals A because we're looking for the amount. It says write an equation to show the amount. So we just choose A to stand for the amount. So 73 minus 5W equals A is our equation. Let's look at part B. Okay, part B says write an equation to represent the number of weeks before she has $58 left in her account. So what is that 58? How does that relate to the equation? Well, it's not the number of weeks, W. 58 is the amount that she has when she takes 73 and subtracts 5 times a certain number of weeks. So instead of having A, we're going to write 58. That's all we do, is we switch where we have A, we write 58. And the rest of the equation is the same. That's all we have to do for B. All right. So C says, solve your equation and show what you did. So if we're solving this equation, we have to find W. That's the missing variable, right? Well, we know that we always have to get rid of any numbers being added or subtracted to the variable term. The variable term is minus 5W, so 73 is being added to the variable term. We need to get rid of 73. What do we need to do to both sides? Subtract 73 from both sides. So 73 minus 5W equals 58 minus 73. We end up with minus 5W on the left. We're going to end up with 58 minus 73, which gives us a negative number on the right-hand side. So here's our equation. We've got a negative number. Remember, this is like minus 5 times W. So the opposite of minus 5 times, we're going to divide both sides by minus 5. Okay? Remember, it's by minus 5, not by plus 5. When we do that, we end up with W, and we also have to divide by minus 5 on the right side. Minus 15 divided by minus 5 gives us 3. So it's going to be 3 weeks until we have $58 left. Okay, so you guys remember we talked about creating a table of values. So what is a table of values again? It's basically a list of it lists the pairs of values for each input value and output value. Okay, so when you have an equation, one of these values is the input value, the other is the output. The input value is the one you put into the equation, so you put X would be the input value, Y would be the output value, that's the answer you get out of the equation. So to create a table of values, you want to come up with some numbers for the input values. So we're going to say X equal 1, 2, 3, 4. Those are easy ones to use to create a table of values. And then we plug X equals 1 into the equation and see what we get for Y. So because Y equals 3X, Y equals 3 times 1 gives us 3. So when X is 1, Y is 3. When X is going to be 2, since Y is 3 times 2, that's going to be 6. Y is 6. So that's how you create a table of values. These blue and green numbers, the matching numbers, are our table of values. Okay, cool. So we're going to look at that in our next question. So Sierra's planning a party. Right on. And the food's going to cost $8 per guest, and the cake will cost $24. Now, first of all, we're going to write an equation someone can use to figure out the cost of the party for any number of guests. So think about what equation you would use using the info we have. And we're going to come up with a table of values for part B. Okay, so our equation, we're looking for one that's going to be to figure out the cost of the party. So the cost is $8 per guest plus $24. So cost equals $24 plus 8 times G, which is the number of guests. That's our equation. Now B says use this equation to find the cost of the party for 4 to 6 guests. So we're just looking at the numbers 4, 5, and 6 for G. That's what we're going to plug in for G. Okay, so we're choosing G equals 4, 5, and 6. When we plug G equals 4 into the equation, think about what happens. We have 8 times 4 gives us 32. 32 plus 24 gives us 56. So cost is 56 when the number of guests is 4. And that's how we find out the table of values. Okay, so these pairs of values are our table of values. Part C says, find out how many guests can come to the party if the total cost is 48. Okay, so again, here's our equation. If instead of having C equals 24 plus 8G, we have 48, that's our cost. So 48 equals 24 plus 8G is our equation, and that's what we need to solve. So we start off with 48 equals 24 plus 8G, and we solve for G. Since we have 8G plus 24, we need to get rid of 24 as our first step, so we subtract 24 from both sides. 48 minus 24 gives us 24 on the left, and on the right side we're left with 8G. So now we have 24 equals 8G. We want just G on the right-hand side. Since we have 8 times G, what's the opposite of 8 times? We're going to divide both sides by 8. 24 over 8 is 3, and we're left with G on the right. 3 guests can come. All right. So at this point, guys, we're done with a review of equations, and we're going to look at things like areas of different shapes at this point. So here we have a rectangle and we have a parallelogram. Parallelograms have sides that are parallel to each other. So we already know that the area of a rectangle is base or bottom times height. Well, it turns out the area of a parallelogram is also base times height. And you can see why this is, because you can see that the area of the parallelogram is the same as the area of the rectangle. You're just taking this area here, kind of cutting it off from the right side, and adding it to the left side. It's really the same shape. So the area of a parallelogram is also base times height. And so if you look at this question here, again, remember guys, when you practice these, practice all the purple questions. Be able to do all of them. If you don't know how to do some of them, just give me a shout. Okay, so what would the area of this parallelogram be? It's going to be base times height, 10 times 6. What is that going to be? 10 times 6 is going to be 60. And remember, area is always going to be something squared. So instead of centimeters, it's centimeters squared. Not too bad, right? Okay, now we're going to look at a question that involves filling in a table. So we know that the area of a parallelogram is always base times height. So what we're missing for this line here is the height. So 4 times this number here gives us 28. 4 times what gives us 28? Well, that's going to be 7, right? We could also get that number by dividing 4 into 28. So that would be the answer, would be 7. Here we have base times height equals some area. Well, we know it's the area of the parallelogram is base times height, so we multiply 20 times 11. It's going to give us 220. Okay, so here you can see the filled-in chart, and we went over how to do it. All right, so we're going to look at areas of triangles in a sec, but I don't know if you guys realize this, triangles are really strong shapes, and that's why these bridges that are known as truss bridges have triangles in them. It makes them really strong. They don't fall down. All right, so this diagram here shows that the area of a triangle is always 1/2 base times height. So it's not base times height, it's 1/2 base times height. So if you had to find the area of this triangle, it would be 1/2 6 times 4. 1/2 6 times 4. 6 times 4 is 24. Half of 24 is going to be 12. So you can probably figure out, based on this, that the area of a triangle is always half of the area of a rectangle. And that makes sense, right? Here's the area of a rectangle, base times height. You can see that the triangle is half the amount of area. So it makes sense that the area of the triangle would be half as much as the area of the rectangle. So if the area of the rectangle is base times height, the area of the triangle is 1/2 base times height. That makes sense, eh? Okay, so 1/2 base times height. So this question says find the area of the two triangles above. So for A, we know it's going to be 1/2 6 times 7. So 1/2 of 6 times 7, which is 42. Half of 42 It's going to give us 21. All right, so 1/2 of 42 gives us 21. That's how we did that one. Looking at the next one, this one's kind of different because we're talking about this triangle, but the height of it is found by dropping a line to the ground from here. Okay, but it's still 1/2 4 times 7. 4 times 7 is 28. Half of 28 is going to be 14. So again, we do the same math for this one. All right, here's kind of an interesting question. It involves both parallelograms and triangles in a way. So it says calculate the area of the blue fabric on the left. And the area of this blue fabric is going to relate to the area of a parallelogram, as you can see. So what's the area of the blue fabric? Let's figure that out first. And we've got some other parts to the question. So the area of the blue flag is 1/2 the area of the parallelogram, right? It's 1/2 the total area. Area of a parallelogram is base times height. In other words, 8.5 times 3. So the blue part is going to be 1/2 of that amount. So it's going to be 1/2 of the parallelogram. So parallelogram base times height is going to give us this amount, 25.5. Half of that is going to give us 12.75. That's the area of the blue triangle. So now we know part A. What's the area of the blue part, the blue triangle? Part B says the price of the blue fabric is $8.40 per meter squared. So for every meter squared, we multiply $8.40. How many meters squared do we have? We have 12.75 of them. So we multiply 12.75 times 8.4. That's going to give us the cost of the blue fabric. So we multiply this cost per meter squared times the number of meters squared, we get $107.10. That's the cost of the blue fabric. All right, for one flag, right? Okay, what does part B say? Or C, I should say. Part C says, how much would it cost for 10 flags? All we need to do is multiply this amount times 10. We do that, we get $1,071. Cool. Okay, so we're talking now everything you wanted to know about perimeter and area. Okay, so here's perimeter. Perimeter is the distance of the outside edge of a shape. And area is the total amount covering the surface of a two-dimensional shape. Maybe you've seen some kind of movie at some point, talks about perimeter, you know, like police officers covering the outside of the building, the perimeter of the building. Okay, so again, perimeter is the distance around the outside edge of a shape. Okay, so we've got a question here. It says the perimeter of this triangle DEF is 16. How long is EF? Okay. Well, we know the length of some of the sides. The length of the right side is 5 centimeters. And the left side has a hash mark, which tells us it's the same amount as the right side. So if we know that the perimeter, the total distance around the edge is 16, we can find the distance for EF. Let's see how we do it. Okay, part B is going to be calculate the area of triangle DEF, and we'll see that in a sec. Okay, so how long is EF, the bottom edge? Well, it's going to be, if it's going to be 16, then 16 is going to be equal to 5 plus another 5 plus whatever EF is. So we write that down. Perimeter equals the distance around the edge. So perimeter, or 16, equals 5 plus 5 plus EF, which we're missing. So since 5 and 5 is 10, we now say 16 equals 10 plus EF. And now just by looking at it, we know that EF equals 6, right? We could do the math, but we know EF is going to be 6. So we've solved that much. Now the next part says calculate the area of DEF. To calculate the area of any triangle, we're looking at the big one here. It's going to be base, which we just calculated, that's EF, We just found that was 6 times height, which is 4. 6 times 4. Actually, sorry, it's not base times height. It's 1/2 base times height. So it's 1/2, 6 times 4. 1/2 of 24 is going to give us 12 units squared. Right on. Okay, so the next one here says if the area of the triangle is this area, find the base. So this time they're giving you area, and you need to use the formula to find the base. Okay, so area equals 1/2 base times height. How are we going to use this formula to find the missing base? We plug in the information we know, and then we figure out the information we don't know, which is the base. So area of triangle equals 1/2 base times height. We know the area, it's this amount, so we write it underneath the area of triangle. 1/2 b, we'll call it, times 21. We know the height. So we have 283.5 equals 1/2 b times 21. We do the math, 1/2 b times 21 is going to give us 10.5 b equals this amount. Now we have an equation. We want to get just b, we're going to have to divide both sides by 10.5, right? When we do that, I just switch the equation around so we have b on the left. I always like b on the left, or variable on the left. So we're going to get b on the left, and we do the math on the right, and we're going to get b equals 28.35. That's how long the base is. Okay, so now we're going to look at the circumference of the circle. We've looked at perimeter and saw that it's the distance around the outside edge of an object. We saw that with the rectangle. Circumference is just the name for perimeter for a circle. Okay? It's just a special name for the perimeter, but it's for a circle. So you can see for this tree here, it's a really large circumference. These people are trying to put their arms around it, and it's really big. There's something like that in Stanley Park in Vancouver. Okay, so what's the formula for the circumference of a circle? It's circumference equals 2 pi r, or circumference, or c equals 2 pi r. Now, since 2 pi is the same thing as diameter, we could also say circumference equals d pi, pi d. Those are two different ways of saying the formula. One has diameter in it, the other has radius. Depending on what you're given, you can use either one. Or you could change things around to use either formula. Okay, so those are two ways of showing the same thing, same formula. All right, so let's practice this then. Let's find the circumference of a circle that has a diameter of 38 centimeters. So we want to use the formula that c equals pi times d, because we're given d. Pi is 3.14, so where we see the symbol pi, we just write in 3.14. We know diameter is 38, so we multiply 3.14 times 38, and we get this number here. And we could use the formula that has radius in it, which is c equals 2 pi r. Since we knew the diameter was 38, the radius is half of that, which is 19. So we just do 2 times pi times the 19, and we're going to get the same number, right? We're just using different formulas to find the same number. Okay, so let's try a problem that helps us solve the radius when you know the circumference. Okay, so a circle has a circumference of 10 centimeters. Find the radius. What strategy are we going to use? How are we going to use that formula, circumference equals 2 pi r, to help us find radius? Well, we use, excuse me, c equals 2 pi r. The question tells us what c is, so we can put in 10 where we see c. Then we're just going to have to solve the equation and find what r is. Sorry about the coughing here, guys. So instead of c equals 2 pi r, we're going to have 10 equals 2 times 3.14 times r. So 10 equals 6.28 r. And now we can solve for r. We're going to have to divide both sides by 6.28, right? And here you can see that. We do that, we end up with r on the right. We do the math here, and we end up with 1.59. That's the radius. Okay, so now we're going to practice putting together a few of the concepts that have to do with circles. We're just filling in blanks, kind of like an earlier question we looked at. So here, we're missing diameter, missing the circumference. Well, how do you get diameter from radius? It's twice as much. Twice as much of 9 is going to be 18. And once we know that, we're going to use one of these formulas. I always like to use the formula that's going to use the number that we're actually given, just in case I did the math wrong. So use the one that has radius in it. It's going to be 2 pi r. So multiply 2 times pi times this 9. That will give you the circumference. Okay, how are we going to do this one here? We know the diameter. Half of it is going to give us the radius. Then to find the circumference, we want the formula that's going to use d in it. So we're going to multiply pi with 3.14 times d, which is this 36. That'll give us the circumference. All right, how about this one? If when we have the circumference, we need to find the radius and diameter, well, we can use either formula to find those, and we'll see that in a sec. Okay, so we've seen how we can figure out the clock and the watch. Let's look at how we're going to figure out the tea bag. And you can look over these calculations if you want later on when you're practicing them on your own. Okay, so for the tea bag, how are we going to do that? Well, circumference is 37. So circumference equals pi times d. Pi is 3.14. So circumference is going to equal, so circumference is 37. So 37 equals 3.14 d. So we divide both sides by 3.14. That's going to help us find what d is. D is 11.78. Find what r is. It's going to be half as much. And that's how we do that. Okay, next question. Next question says, the racetrack consists of a rectangle, this part, and 2 half circles. What is the length of one lap? So, what measurements are we going to add together to find the total length? In other words, the total length of a lap. And how are we going to find the total distance around 2 half circles? Just some questions to think about. To find the total length, we're going to add 56.8, I should say, plus another 56.8, plus we're going to add the circumference of one whole circle. Okay, so we're going to add the circumference. We've got 2 half circles, but since there's 2 of them, we're going to add the distance around the edge or the circumference of one of the circles. Okay, so I made a mistake here in the math here because I only added one 56.8. Should be 2 of them, right? Because we have 2 sides there. The circumference of the circle, we know the radius of the circle is 21.7. So r is 21.7. We plug that into the formula. So the formula is 2 pi r. So 2 times 3.14, which is pi, times the radius, which is 21.7. So here is the circumference of a whole circle. We add the circumference of the whole circle to a 56.8, and then to another 56.8. So whatever answer we get here, we need to add on another 56.8, and that will give us the correct answer. Sorry about messing me up with that, though. I should have added 2 56.8s. All right. So we've looked at the circumference of a circle. Let's look at the area of a circle. That uses the formula area equals pi r squared. In other words, pi times radius times radius. Okay, so if we have that, and we're looking at an example here, if 7 is the radius, it's 3.14 times 7 times 7, and that's going to give us this amount here. Cool, so what could you actually use this stuff for, like the area of a circle? In real life, what could you actually use that for? Well, you know what? The other night, I was looking at a new pizza shop that was opening up, and I thought, okay, you know, I'm a math teacher, I know a little bit about areas of circles. How can I figure out which pizza deal is the best deal? So what I did is I looked at what they said on the website was the diameter for a small pizza, diameter for a medium, and diameter for a large, and I looked at the cost of each one, and I was able to compare, cost divided by area, and I found the cost per area. And whichever pizza had the lowest cost per area, that's the one that's going to give you the best deal. And most of the time it's a larger pizza, but maybe not always. Okay, so we've got another question here. We're going to use the formula for the area to find the area of a circle with a 38 centimeter diameter. So D is 38, but our formula has R in it. So R is half of diameter, so it's going to be 19. So it's going to be pi times 19 times 19. So here's the math. Pi times 19 times 19 gives us this answer as the area. Remember, it's going to be centimeters squared. Area is always something squared. And always make sure when you put down your answers that you put the units. Centimeters squared, meters squared, units squared, whatever it is. All right. So here's another question, interesting question. I don't know if you guys have ever played Twister before. It's got these different colored circles. Everybody spins the spinner thing, puts their foot on a certain color, you get all twisted up. So the question says, about what fraction of the game mat is covered in circles? So, to find that, what formula do you think we're going to use to find the fraction of the game mat that's covered in circles? Well, the fraction covered in circles is going to be the total area of all the circles divided by the total area of the mat. That's going to be the fraction covered in circles. How do you find the total area of all the circles? If you find the area of one circle, since there's 10 of them, you multiply that area times 10. How do you find the area of the mat? Easy. Multiply length times width, right? Okay, so find the area of one circle. Well, we can see that it's labeled that the diameter is 80, so R equals 40, right? We plug it in, pi r squared, pi times 40, we get this amount for the total area of 10 circles, because we multiplied them by 10, right? The area of one circle. Total area of the mat, length times width, too easy, right? This amount here. So we divide total area of all circles by the total area of the mat. That's going to be the fraction. The question says, about what is that fraction? About how much is it? And we can see that that is approximately 5/12, right? 5/12 is also close to half. So about half the mat is covered in circles. Cool. All right. So here's another question. Find the total area of this figure. Well, we can see we have two areas, two shapes together. So what two areas do we have to add together? And what formula are we going to use to find each one of the areas? Okay, just something to think about. Now I should let you know, this should have been labeled here. Each one of the sides labeled with one of those marks is equal. And we can see in the diagram that one of them is 5 centimeters. So that means that any one of them that has that hash mark on it is 5 centimeters long. So, again, we should have them labeled here. So what two areas are we going to add together to find the total area? We're going to add the area of the rectangle plus the area of a half circle. So, what's the area of the rectangle? It's length times width. Okay, so we've got 5 times a 5 here, and another 5 gives us 10. 5 times 10 gives us 50. That's the area of the rectangle. Okay, so we got that here. Area of rectangle is 50. But what's the area of half a circle going to be? Well, we know the area of a circle is pi r squared, so we find 1/2 of pi r squared. What's r going to be? R is going to be 5, right? See this here, radius is going to be 5. So it's 1/2 pi r squared. So here's pi. Here's r, which is 5 times 5. And we're going to multiply it by a half because it's a half a circle. The area of the half circle is this amount here. We add this half circle area to the area of the rectangle. We get our total area, which is going to be 89.25 centimeters squared. All right, so guys, again, I know I say it many times, but again, please practice all the questions, all the purple ones here after you watch the recording. And if you have any questions at all, please give me a shout. I really want to see you do well, but it's important that you ask questions as well if there are any questions at all that you're not sure how to do. I want to thank you guys for watching this. I want to encourage you guys to work hard until the end. You know, just a few more months to go to the end of the year, but it's important to work hard to the end. I know it's spring, but again, keep working hard, guys. I know you can do it. And take care, guys. Have an awesome day. Bye for now.